Hello everybody, welcome back to physics concept session. In this session we are going to discuss current, electricity and moving charges along with its magnetic effects. We'll have the structure of the lesson: current, electricity, Ohm's law, drift of electrons, resistivity of various materials and its temperature dependence, electrical energy, cells EMF, internal energy, cells in series and parallel, Kirchhoff laws, of course, rules, Wheatstone bridge. These things we are going to discuss in this. Electric current. It is the net charge flow through any given cross section of a conductor in time t is the average current actually. Rate of flow of charges through the given cross section is instantaneous current, that is dq by dt. Q by t always indicates average current, dq by dt indicates instantaneous current, and whenever you want charge q is equal to integral I dt over an integral limits t1 to t2. Slope of the charge time graph, charge by time, will give you the current. Area of current time graph gives the charge flown. Area means the product of the two things, slope means division of the two things. Simply you can put in your mind. If a point charge q is revolving in a circle of radius r, then it causes current. That current is I is equal to q by t, that is equal to fq, frequency into charge, that is equal to omega 2 pi into q, or vq by 2 pi r. This is the current. So whenever you want current due to a revolving electron or due to a revolving charge, you can use simply vq by 2 pi r. Given electric field E, mass m, charge of electron E, and relaxation time is tau, then time is tau, then current I is equal to n1 plus n2 into E by t is one of the formula, and I is equal to NEA Vd, where Vd stands for drift velocity, and current I is equal to Ne square E A tau by m into E. These are the formulae for current passing through a conductor. And mobility, drift per unit field is called mobility. Mobility is equal to drift per unit field Vd by E, that is, and J equal to sigma into E equal to J rho. Drift velocity is given by I by NEA, I by NE, E by m into tau. These are all drift velocity related formulae. Drift velocity increases with temperature, decreases with area of cross section. Conductivity sigma is equal to Ne square by m into tau. Conductivity sigma is equal to Ne square by m into tau. At constant temperature, the current through a conductor I is directly proportional to the potential difference V across it ends. V is proportional to I, and V equal to IR, where R is the resistance. And this is current, cross sectional area, potential difference, the related graph. So that you are going to have slope of Vi graph is the resistance. Resistance R of a conductor depends upon nature of the material, dimensions, and resistance, it depends upon even temperature also. So if the conductor is stretched or elongated or drawn, twisted, then the volume of the conductor remains constant. Hence R is equal to rho L square B, R proportional to L square X. L is the length of the conductor, then fractional change or percentage change in resistance equal to 2 times of percentage change in length. R is equal to rho V by A square, so R is equal to 1 by A square or 1 by R to the power of 4, where R is the radius of the conductor. Percentage change in R is equal to minus 2 times of percentage change in A, that is equal to minus 4 times of percentage change in radius of curvature of the cross section, or you can feel. In terms of mass of the wire, R is proportional to L square by m. Variation of resistance or resistivity with the temperature, that is rho T is equal to rho naught of 1 plus alpha T minus T naught, which is nothing but temperature difference. As rho is changing, R also changes. RT is equal to R naught of 1 plus alpha into delta T. And these are all the respective things. If the resistance, yes, at temperature T1 and T2 are given, then alpha is equal to quotient of temperature resistance is R2 minus R1 by R1 T2 minus R2 T1. Graphs between variation of resistivity and with temperature is for metals alpha greater than 0, for alloys alpha greater than 0, and for other things for semiconductors alpha less than 0. For metals alpha even greater than 0 but not constant, for alloys greater than 0 but constant, but whereas what you call semiconductors, it decreases with increase of temperature. So alpha value decreases with increase of temperature. That's why a falling curve. Next, a conductor such as mercury becomes a superconductor at low temperatures. So it abruptly rises at one particular temperature. And color code for resistances. Of course, color codes in certain years is deleted from the portions, but can be replenished soon. So first band is digit 1, second band is digit 2, third band is the multiplier, and fourth band is the tolerance. Sometimes fourth band will be absent, that we will check, and so that we can have this table. B.B. Roy of Great Britain had a very good wife with gold silver necklace. So this is the memory aid given by my teachers, and I am giving to you. B.B. Roy of Great Britain, you can see the left side. B.B. Roy of Great Britain had very good wife with gold silver necklace. So if, see, many people's favorite color is black, so you can start with black. Just a memory aid actually. Okay, no sir, I like brown sir, it's okay, but black is the starting one. So black, brown, red, orange, yellow, green, blue, violet, everybody knows. Next, out of VIBGYR there is another G which is grey, out of VIBGYR W is white, and gold, silver is separate things. Then you need to start with 0 onwards and 10 to the power of 0 onwards. So these are the table things. And the fourth band, if it is the gold band, then it will have an error or tolerance of 5%. If it is a silver band, 10%. If it is a no band, then 20% tolerance. And also in multiplier these colors are there, then 10 power minus 1 and 10 power minus 2 also you need to notice. Next, series combination of resistors. 3 resistors connected with a cell, then current through them will be same, potential difference is divided among them, V1 is to V2 is to V3 is R1 is to R2 is to R3, and so then effective resistance is R equal to R1 plus R2 plus R3, everybody knows. Next, when resistances are in parallel, then current will be divided but potential difference will be same, and current is inversely proportional to the resistance, so its ratio will become I1 is to I2 is to I3 will be 1 by R1 is to 1 by R2 is to 1 by R3. When two resistors are connected in parallel, then like only 2 resistors, so same thing you can apply. Next, total current I is equal to I1 plus I2, potential difference will be V1 is equal to V2 because they are in parallel, and I1 R1 equal to I2 R2, and I1 is equal to R2 by R1 plus R2 into I, and so. Next, n identical resistors connected in series, then nr is the equivalent resistance. If they are connected in parallel, r by n is the equivalent, and a wire is cut into n equal parts and then connected into parallel, then the effective resistance will be r by n square. If n wires of equal resistances are given in number, then combination that can be made to give different resistances is 2 power n minus 1. A wire n of equal resistance are given, the combinations that can be made to give different resistances is 2 power n, and a wire is bent in the form of a ring of resistance R, then equivalent resistance between P and Q is total resistance, suppose say R, and it is bent into a circle, and the equivalent resistance between P and Q are any 2 points on the circle, then R into theta into 2 pi minus theta by 4 pi square. After calculation everybody will get this only. This is not the time to discuss the calculation. Calculations you need to follow another video. If a uniform wire of here, this video is strictly meant to complete one chapter in a specific time. So it's a good revision. If a uniform wire of resistance R is stretched to m times, then resistance will be M square R because R is proportional to L square. And resistance of each resistance is R2 is equal to M square R by N. And resistance across diagonally opposite ends, resistance across opposite diagonal ends R not equal to N by 2 R2 by 2 or M square R by 4. Next, and so if two wires of resistivities rho 1 rho 2, lengths L1 L2 are connected in series, then rho is equal to rho 1 L1 plus rho 2 L2 by L1 plus L2. If L1 is equal to L2, rho equal to rho 1 plus rho 2 by 2, it will be because L1 equal to L2. Next, if L1 equal to L2, then conductivity sigma is 2 sigma 1 sigma 2 by sigma 1 plus sigma 2, combination of wires it is. Conductivity sigma equal to sigma 1 plus sigma 2 if n wires each of resistance R are connected in the form of a closed polygon. Equivalent resistance across two adjacent corners is R equivalent is equal to n minus 1 by n into R. R equivalent is equal to this into R. So R equivalent is n minus 1 by n into R. R, and all are R's. Then adjacent corners, this is the answer. And equivalent resistance across the diagonally opposite corners 5R by 6. Face diagonal 3R by 4. These are all so many times frequently asked questions. Two adjacent corners 7R by 12. Kirchhoff laws. Algebraic sum of currents at a given junction is 0. So currents coming in is equal to currents coming out. So inward current taken positive, outward current taken negative. So this will come. And Kirchhoff's second law, KVL, algebraic sum of potential differences in a closed loop is 0. It is based on the conservation of energy. Law of conservation of energy is KVL. Law of conservation of charge is KCL. Okay. In this example, V is equal to IR1 plus IR2. Wheatstone bridge, application of Kirchhoff laws to this picture is Wheatstone bridge. Balancing condition is P by Q equal to R by S. And P equal to Q equal to R equal to S, then the bridge will be most sensitive. That means 50 centimeters balancing it actually, but it will be most sensitive. Equivalent resistance is R1 R2 by R1 plus R2, that is P plus Q R minus S by P plus Q plus R plus S when bridge is balanced. Otherwise, this is not equivalent. There are 7 closed meshes in a Wheatstone bridge. 7 closed meshes in a Wheatstone bridge. So you have to write 7 equations to solve other things. Meter bridge, it works on the principle of Wheatstone bridge. Meter bridge will look like this: left gap, right gap, and a wire of 100 centimeter resistance. When the meter bridge is balanced, R by X equal to L1 by L2, that is equal to L1 by 100 minus L1. So X is R is equal to, or X is equal to, you can find it up. If the resistance of the left gap or resistance in the right gap increases, if the resistance in the left gap decreases, resistance in the right gap increases, balancing point shifts towards left. In which side resistance is less, balance point will be towards that side actually. Meter bridge is more sensitive if L1 is equal to 50 centimeters and R is equal to X. Internal resistance of a cell, every cell will have its own internal resistance because inside there is a mechanism to transfer charges. So that causes resistance. I equal to NE by R plus NR when E effective is NE. Terminal potential is V is equal to E minus IR, where IR is the potential drop across the terminals of the cell. And the cell in an open circuit, V is equal to E. In open circuit it reads EMF, the voltmeter reads EMF. In closed circuit it reads terminal voltage. If the cell is discharging, V is equal to E minus IR. And if the cell is charging, then V equal to E plus IR. Series combination of identical cells will give you effective EMF is equal to NE by NE, and the current in the circuit is NE by R plus NR is the current. If R is very smaller, then NE by NR, that is equal to E by R is the current. If R is very greater, then I equal to NE by R. So you want more current, then you have to use the second condition, right? For long life you have to use the first condition. R small will give you long life, R greater, very greater will give you more current. Wrongly connected cells in series. Effective EMF of the combination is E is equal to N minus 2M into E, where N number of cells, M wrongly connected cells. Current through the external resistor I is equal to N minus 2M into E by R plus NR. And parallel combination of identical cells will give you E by R plus R by N is a current, and effective EMF will be E only when the cells are identical. Otherwise you have to use Kirchhoff laws. If R is small, then N E by R is the current, and if R is greater, then E by R is the current. So in this also, whatever you want, based on that we are going to follow. And mixed grouping of cells. Some cells are in series, and such rows are connected to meet the requirements of current and potential difference. This is mixed grouping. Total number of cells M into N, where N is cells in the series in one row and M rows of cells are in parallel. So current in this external resistance R is given by NE by R plus NR by M. Potentiometer principle. Potential drop across a principal potentiometer wire is potential drop across the potentiometer wire per unit length is constant. That is V by L is equal to constant. V by L is equal to I lambda or I rho or I phi, whatever. So V by L is equal to I lambda E by R plus small r plus capital R plus Rs into R by L. Where when specific resistance rho of potentiometer wire is given, then potential gradient V by L equal to I rho by pi R square. Internal resistance of a cell is small r is equal to E by V minus 1 into R dash or L1 minus L2 by L2 into R dash. E by V equal to L1 by L2. Next, comparison of EMFs of two cells. E1 by E2 is L1 by L2. In sum and difference method, E1 plus E2 by L1, E1 plus E2 by E1 minus E2 equal to L1 by L2, or E1 by E2 is L1 plus L2 by L1 minus L2. Sensitivity of potentiometer is directly proportional to potential gradient inverse. That means inversely proportional actually. So L by V or L by IR or LRT by ER. Joule's law. Q equal to I square RT, or amount of heat produced is equivalent to work done, and electrical energy is equal to potential, what you call the work done to maintain the current in an electrical circuit for a given time. Electrical energy is equal to Vt, that is equal to Pt, that is equal to I square RT. This is V square T by R. Next, one household consumption of electrical energy is measured in kilowatt hours. 1 kilowatt hour is equal to 36 into 10 power 5, and E is equal to WH by 1000 kilowatt hours. Electrical power is equal to W by T, that is V into I square R or V square by R. And if resistance are connected in series, I is same, so P proportional to R. If resistance are connected in parallel, then V is same, so P is inversely proportional to R. Resistance R under the potential difference V dissipated is P equal to V square by R, and these are all normal things. Resistance of a given electrical appliance R is equal to Vs by I or Vs square by W. Resistance for a given appliance bulb or heater is constant and is given by R is equal to Vs by I. Inbuilt resistance we'll call it as, this is always constant. If you change external potential difference, then external current flowing through it will change, but inbuilt resistance will be changed. So Vs by Vs square by W is the formula for it. Bulbs connected in series, equivalent power equal to 1 by P equal to 1 by P1 plus 1 by P2 plus 1 by P3. Bulbs connected in parallel, then P equal to P1 plus P2 plus P3 and so on. So in our household circuits, bulbs will be in parallel, so P equal to P1 plus P2 plus P3. And fuse wire generally prepared with tin and lead alloy. 63% of tin, 37% of lead. It should be high resistivity, low melting point. R be the resistance of fuse wire, R is equal to rho L by pi R square. And the heat produced in the fuse wire, H equal to I square R. Theta is the increase in temperature of the wire, and K is a constant. Theta is equal to I square rho by 2 pi square R cube K. Whatever, whenever is needed, you can use. For a given material of the fuse wire, I square is proportional to R cube. maximum power transfer theorem, that is current in the circuit I equal to E by R plus R, power dissipated in the device is P equal to I square R, maximum power dissipated is dP by dr equal to 0, and whenever if you obtain the root, R is equal to R will come. Whenever external load resistance equal to internal resistance, then we can conclude that power dissipation is maximum. Moving charges and magnetism. This includes magnetic force, motion in a magnetic field. Which one? A charged particle's motion in a magnetic field due to a current element by Savart's law, magnetic field on the axis of a circular current loop, Ampere circuital law, solenoid, force between two parallel currents, the dipole, torque on current loop, magnetic dipole, the moving coil galvanometer. These things we are going to discuss. Magnetic field due to a current element using Biot-Savart's law is mu naught by 4 pi I into dl bar cross r bar by r cube. Many years they asked this vector form in a competitive examination. Mu naught by 4 pi I into dl bar cross r bar by r cube, and mu naught by 4 pi I dl sin theta by r square into n cap. The direction of dB bar is denoted by dl bar cross r bar. Using right hand thumb rule you can find it up. And mu naught permeability of the free space, that's value is 4 pi into 10 power minus 7 Henry per meter. dl bar is along current element ideal, then dB is equal to mu naught by 4 pi q into v bar cross r bar by r cube. Relation between permittivity of free space and permeability of the particular space and speed of light is c equal to 1 by square root of mu naught epsilon naught. At many chapters we have this. And magnetic field due to current carrying straight wire is B is equal to a finite wire. Mu naught by 4 pi I by A into R, mu naught I by 4 pi A into sin phi plus sin phi 1 plus sin phi 2. Many books it is sin alpha plus sin beta, not a big task. And if it is an infinite long wire, then mu naught I by 2 pi A. Yes. Magnetic field on the axial point P at a distance d from the center of the loop is Bx is equal to mu naught Ia square by 2 into A square plus d square whole power 3 by 2. And By will be 0, but in electricity By need not be 0, and that means Ey need not be 0. Here it is so. And for a coil of n turns, B is equal to, for a coil of n turns, B is equal to mu naught Ni A square by 2 into A square plus d square whole power 3 by 2. For a far away point, B is equal to mu naught I A square by 2d cube. And orbital angular momentum mu1 is equal to E by 2 me into L, where mu1 is magnetic moment of circulating current, whatever. Next, Bohr's magneton is, here two equal to's are missing. Let me put them, two equal to's. Just in a minute I can add them. Two equal to's, equal to, and one more equal to. If we take particle with charge instead of electron, just here equal to's are missing and I kept them, not a big task. And Bohr's magneton is equal to E by 4 pi meh, which is equal to 9.2 into 10 to the power of minus 24 ampere meter square. Magnetic moment is magneton. Next, Ampere circuital law. Line integral over B dot dl for a closed path is equal to mu naught times of current flowing through that path. So B dot dl equal to mu naught I total. And for multiple currents, you have to take as per the sign convention, whoever along our thumb positive current, whoever opposite to it negative. So these four fingers you have to set in the direction of the integration, and this thumb will give you direction of the current. If the current is in that direction, take positive. If current is opposite direction, take negative. Next, due to current carrying circular loop, general formula B is equal to mu naught I by 2A by theta by 2 pi, if theta is the arc, magnetic field due to circular current carrying conductor. This is. And for full circle mu naught I by 2A, for semicircle mu naught I by 4A, and quadrant of a circle is mu naught I by 8A. Due to solenoid and toroid, Magnetic field due to ideal solenoid, infinitely long, L is very greater than R, and B is equal to mu naught Ni. N is number of turns per unit length, not number of turns, or it can be capital N by L, and mu naught Ni by 2 pi R. This is also true. Mu B equal to mu naught Ni by 2 pi R, or B equal to mu naught Ni. And here there must be a space between Ni and N, otherwise it's confusing. Just a minute, I will change in that. Radius of circular path R is equal to mv by bq when a charged particle is projected into a magnetic field at right angles. Yes. And time period of one revolution is 2 pi m by bq or qb. Angular frequency omega equal to bq by m. And cyclotron frequency is same bq by 2 pi m. And time spent in magnetic field T is equal to m by bq into 2 pi minus theta. Angle of emergence delta is equal to sin inverse d by r, and when insufficient field is there, otherwise that will be 2 pi minus theta only. What is that? If the velocity of charged particle at an angle b, then that means a charged particle is projected into magnetic field at an angle theta, not at 90 degrees. Then it follows a helical path and it moves forward with v cos theta and makes circles with v sin theta. So radius of curvature will be mv sin theta by bq, and time is independent. Time t equal to pi m by bq only. Pitch is equal to distance moved in one revolution is called pitch. That is equal to v cos theta into t. The picture is so nice and very clear to understand, right? It's a good picture. And Lorentz force is a combination of electric and magnetic field forces. EQ plus Q into V bar cross B bar. This is magnetic field force. Q into E plus V bar cross B bar. And special case, E perpendicular to B perpendicular to V. This situation, possibility of Q moving undeviated. V equal to E by B is the condition. When both electric and magnetic fields are perpendicular and the charged particle is moving undeviated, then V equal to E by B. And force on a current carrying conductor is F is equal to I into L bar cross B bar, or Bill sin theta. And force between two parallel current carrying infinite wires is current flowing in the same direction. F by L is equal to mu naught by 4 pi to I1 I2 by D. And magnetic moment M bar is equal to NIA. N is equal to number of turns, and A is area of the particular current loop, and I is current. Potential energy equal to minus MB. Deflecting torque is equal to BINA when a rectangular coil is placed in a magnetic field. Number of turns are N, and restoring torque tau is equal to C theta. BIAN or BINA is equal to C theta. I is equal to C theta by BAN for MCZ. I is equal to K theta, where K is galvanometer constant. And current sensitivity SI is equal to theta by I, that is BAN by C, or d theta by di. Voltage sensitivity is also d theta by dV, which is BAN by CR. Tangent galvanometer B equal to BH tan theta is the tangent law, that is the principle for tangent galvanometer. For that the formula is mu naught Ni by 2R equal to BH tan theta, or I equal to 2R BH by mu naught N tan theta. I is equal to K tan theta. K is reduction factor, 2R BH by mu naught N. Conversion of galvanometer into ammeter. When galvanometer connected into ammeter with a small resistance in parallel, which we will call shunt, then it will be converted into ammeter. And Iz is equal to Is by G plus S, or S is equal to G by N minus 1, G by N minus 1, and R effective is equal to G into S by G plus S. Galvanometer into voltmeter is high resistance must be connected in series, then it will be converted into voltmeter. Then V is equal to Iz into G plus R, or here one more formula I will give you, that is this one. For voltmeter, resistance needed R equal to G into N minus 1, where N is equal to V by Vz. Okay, and here it's okay, it's very clear. G by N minus 1, n equal to I by Ig. Similarly, G into n minus 1, n equal to V by Vg. Then it will be good. Now keep on practicing. This is a theory concept session. We will discuss numerical problems in the next session.